Hey guys, it's Miss Goldenberg. Hope you guys are having a good day so far. This is our first of two review days to kind of finish out Unit 8 on area. I just sent out a survey to Google Classroom, except for you won't see this until tomorrow, but there is a survey to see what time you guys want to do office hours. And I'm going to try and have availability in the morning and the afternoon for my classes, so I'm just trying to figure out a good schedule to start like at the end of this week or at the beginning of next week at the latest. So here is our math meme of the day. Pentagon, octagon, omnagon. Or omnomnomnogon. Just thought it was kind of cute. I used to love playing Pac-Man when I was a kid. We'd go to the arcade and would play there on field trips at summer camp. Okay guys, so reviewing some area, I'm going to go through all the problems. You guys have this printed out in your packet. You can skip around, you can do some of them, right? Whichever ones you feel like you need more practice. Normally in class this would be kind of a pick what you need day, right? So feel free to skip around in the video and go to practice that you guys want to have practice in. Okay, so first one is Station 1, area involving special right triangles. So remember, special right triangles come up quite a bit in a lot of our area problems. I'm going to draw like a quick reference for us. So I'm going to do our 45, 45, 90. Remember, your two legs are congruent, and you can call them like x and x. Your hypotenuse would be x square root of 2. For our 30, 60, 90, get my angles there. You're going to have x, your smaller leg, 2x is going to be your hypotenuse, and your longer leg is going to be x square root of 3. Okay, so I'm just going to leave that there for reference. Now notice when they say exact value, they want you to leave your answer in terms of square roots of 2, square roots of 3. The first one says we're finding the area of a parallelogram. Remember, the area of a parallelogram is just base times height. Remember we talked about if you cut off this triangle, for instance, and fit it over here, you would make a rectangle, right, if I cut it off. So that's one way to think about why it works out the same way as a rectangle. So let's see, our base is the same as the side length of 20, right, because your opposite sides are congruent. So our base of our shape is 20. Now the trick is we don't know what the height is, right, we're missing that height. In order to find the height, my height makes a perpendicular angle with my base. So it looks like I'm focusing in on this orange triangle. And it is a 30, 60, 90. So it looks like we're given 10, and 10 is matching with the 2x. To get the smaller leg, or like the base if you want to think about it, we're going to divide by 2. So 10 divided by 2 gives us 5. And then to get to our longer leg, or the height in this case, we're going to do times root 3. Right, so 5 times root 3 is 5 root 3. So base times height is going to be 20 times 5 root 3. This is going to be just 20 times 5, which is 100 with the square root of 3 tacked on there. We don't know units, so I'm just going to say units squared. One way to think about why it's 100, it's really similar to if I asked you to do 20 times 5x, right? You would just do the 20 and the 5 and call that 100x. Same kind of thing. The x or the root 3 kind of goes along for the ride, so to speak. Okay, our next one, and keep in the back of your mind, it's a 30, 60, 90, maybe a 45, 45, 90. One thing you want to keep in mind is how would you recognize it on an assessment if I didn't tell you that you were dealing with the triangles, right? So you want to keep your eyes out for the clues that you're seeing. Let's see, it's an isosceles trapezoid. So if I draw that, that means my two legs are congruent. My base angles are congruent, really similar to an isosceles triangle, right? It has an upper base of 12. So the little base is 12. The legs are both 14 square root of 2. 14 square root of 2. And the lower base angles, it tells me, are 45 degrees. So I'm going to label that these are both 45 degrees. And we need to find its area. Quick reminder, area of a trapezoid, base 1 plus base 2. Times your height divided by 2. So if we want to find the area of the trapezoid, we are missing our larger base, right? We've got our upper base, we don't have our lower base. So make a note like you're missing the other base. as well as the height. We don't know either of those. So the first thing I would probably do is I would draw on a height, right? Here's a height, here's a height. It's not very well drawn, sorry. Remember, your height makes a right angle with the base. If I'm looking at those two triangles that are kind of on the outside, right, it's got 14 root 2 and 45 degrees and 90. That's going to be our 45, 45, 90 triangles. So that means your two legs are congruent, and that's 14, and so is this. So I'm going to label my 14s, which means if I was to kind of plug stuff in, I know the one base is 12, right? Plus my other base is going to be, this one's a little trickier to see. You want the full bottom, which is 2 14s, as well as you also have 12 along in the middle. So you're going to have to do 14 plus 14 plus 12, which comes out to 40 for your total big base. Times our height. Our height is 14, right? And that's coming from the height of the trapezoid is that one side of your 45, 45, 90 triangle. Then we're going to divide by 2. So it looks like we've got 52 times 14 divided by 2. Okay. If I plug that into my calculator, we're going to have 52 times 14 divided by 2. Looks like it's 364. And units squared. Okay. I would say the first one is definitely a core problem, right? Number 2 is a little bit more detail, more work, but it's also a pretty core problem. It's dealing with your special right triangles. This one's a good one. This one says find the area of the shaded region of the if the circumference of the circle is 24 pi. I would say this one's more like a mixed problem. Your more straightforward problems like find the area are typically core. A mixed problem is if you kind of have to do some working backwards. Anytime they tell you what the answer of something is, that means you have to work backwards to find some kind of a measurement. Okay. So let's see. If that's the circumference of the circle, if we think about our circumference formula, that's 2 times pi times radius. Some of you guys might prefer pi times diameter. That's fine too. So if I know 2 times pi times radius is equal to 24 pi, right? That means pi's match up. So that means that 2 times the radius is 24. So if 2 times the radius is 24, that means the radius has to be 12 long. So if I label that in the picture from the center to the edge, that's 12. Let's see. We're going to assume that this is a regular hexagon. So that means that if the angle is 60, right, the upper angle is 60, you've got 30 and 30. So you've got a nice 30, 60, 90 here. So for 30, 60, 90 triangles, right, we can use that to find different measurements. We want to find the area of the hexagon as well as the area of the circle to then subtract them and get what's left over, right? So we're going to find hexagon area. We're going to do circle area over here, and then we're going to do circle minus hexagon. So for the hexagon, remember we have to break it up into triangles. We're going to have 6 triangles, so if I can find the area of one triangle, right, I'm going to do area of one triangle times 6. So in order to do that, I need the area of one triangle, which is base times height divided by 2. Now, because this is 12 as a side, that means all your sides are going to be equal because it's an equilateral triangle. Only because you have your 60 degrees, 60 degrees, 60 degrees. So if all of the angles are the same, that means all your sides are also the same. So that means my base is also at 12. We're missing height. Now think back to our special right triangles. If I'm trying to find the height, I've got a 30, 60, 90 triangle. I'm going to redraw it out here on the side. If I've got 12, I'm going to divide by 2 to get 6 as my base. I do 6 times root 3 to get 6 root 3 as my height. So I'm going to replace the h with a 6 root 3. Now remember it said to leave your answers exact, so we want to leave the square root of 3 alone. So I'm going to do 12 times 6, 72. So I've got 72 root 3 divided by 2. If I do the 72 cut in 2, right, that's all you got to do. Divide by divided by 2, right? 36 root 3, and that's coming from 72 cut in half. To get my area of my circle, it's going to be pi, pause, I only did an area of one triangle. I need to take this number and do it times 6, because there are 6 triangles. So 36 times 6, that's going to get me 216 according to my calculator. 216 root 3. So far I found 216 root 3 is the area of my hexagon. To get the area of my circle, I'm going to do pi times radius squared. Pi times my radius we said was 12 squared, so 12 times 12 is 144. We'll leave the pi alone. So we have to do 144 pi minus 216 root 3. Now, going back to the top of the page, they told us to leave exact values. That was only for number 1, I guess. So I guess for number 3, you can really do a couple things. You can say that your answer is 144 pi. The bigger circle, take away the 216 root 3. That would be your exact answer in units squared, because I don't think they told us units. If you wanted to give a decimal answer, that'd be fine too. So my decimal answer would be 144 second caret key on the right pi minus 216 times the square root of 3. Looks like it comes out to about 78.2. I'm going to round it to 23. So there are our 2 versions of our answers. And once again, remember, feel free to jump around. You don't have to do all the problems. They're just there for extra practice. So if you feel like you needed practice with just special right triangle problems, then these are really useful, right? We're going to go through the other problems. Feel free to jump around as you need. This one is area involving trig. So sometimes if we need a certain side, and it's not a special right triangle, we have to use our old tool from last unit. So let's say I want the area of the triangle. Area of a triangle is base times height divided by 2. And remember, the base and height have to make a right angle. So if these 2 sides are making right angles, I need to find both of them, which kind of stinks. So let's see. I know that this is my focus angle. I'm going to label opposite. Hypotenuse is always across from the right angle, which makes my last side adjacent. Okay, and I want to find, it doesn't really matter which side I find first. I'm going to pretend I want to find opposite. I'll call that x. And I have the hypotenuse. If I think about my SOHCAHTOA, I want which one has an O and an H, and that's so. So I'm going to be using sine of 59 degrees. Remember, if I take sine of an angle, that's telling me one side on top of the other, right? The opposite side, which is x, on top of hypotenuse, which is 17. So all sine of an angle is, or cosine of an angle, or tangent, it's just a ratio of 2 sides. And the phrase SOHCAHTOA tells you which 2 sides you're putting on top of each other. So sine of 59 degrees, that's just a number. So it looks like it's 0.86 if I round it. 0.86 equals x over 17. Now from here, remember our strategy is we put it over 1, and we're going to do some cross multiplying to find what x is. So it looks like 1x is equal to 0.86 times 17. I'm going to be using my exact answer on my calculator. If I just immediately do times 17, it will get me the final answer of about 14.57. And at this point, you kind of have to round a little bit, which is okay. To get my last side, I've now got 2 sides of my triangle. Right? If I redraw my triangle, I've got the 17, the 14.57. You can use Pythagorean theorem. So you can say that y squared, if I call my adjacent side y, plus 14.57 squared equals 17 squared. Okay, so 17 squared, according to my calculator, is 289. If I take my 14.57 and square it, I get 212.28. Okay, sorry about that. I froze it to try and finish it up before my 15 minutes are over. I used Pythagorean theorem. I found that y is about 8.76. If I do base times height divided by 2, 8.76 times 14.57 divided by 2, which comes out about to 633.2 units squared. I'll finish the rest in the next video.